In this video, we are going to be reviewing the second half of the course. For the first half of the course, please see one of the previous videos. But today we are going to focus on solving quadratic equations and trigonometry. So, in solving quadratic equations, there's two ways that we can do it. And we can solve by factoring, or we can solve by using the quadratic equation. Either way, essentially what we're doing is we are trying to find the solutions for a quadratic equation. And the solutions for a quadratic equation are the roots, zeros, or x-intercepts of the parabola. All these terms mean the same thing, so they can be used interchangeably. The first example we're going to look at is solving by factoring. And the steps for solving by factoring is, first, we need to make sure our equation is in standard form. And standard form is the ax squared plus bx plus c, and we want to make sure that it's set equal to 0. So that's the first thing that we want to do. The second step is we want to factor it. So we want to factor our equation, and we should get our factors, and then we're going to set each factor equal to 0 and solve for x. Then we can check our solution by plugging those x values back into the equation, and it should equal 0. So we're just going to go through a couple examples. So in the first example, we have x squared plus 5x minus 24 equals 0. So this is already set up in the right form. So now we just need to factor this. And again, when we're factoring, we're going through the same process when we were factoring equations in general. So we could look for, is there any common factoring? In this case, no. Are there any difference of squares? No. Any perfect squares? No. Is it a complex trinomial? Meaning, is there a number in front of the x squared? In this case, no. So that leaves us with a simple trinomial. So that means we are using our product and sum method. So looking for two numbers that multiply to negative 24, or the last number, and they add to 5. So again, you're looking for two numbers that multiply to negative 24 and add to 5. In this case, our two factors are going to be 8 and negative 3. Again, because 8 times negative 3 equals negative 24. 8 plus negative 3 equals 5. So that is how we find our factors. And again, it might take a little while, it might take some guessing and checking, but you should get 8 and negative 3. Because it's a simple trinomial, we just put them into brackets with x. So x plus 8 and x minus 3 will equal 0. So we factored it, it's set equal to 0. We need to now set each factor equal to 0. So x plus 8 equals 0, and x minus 3 equals 0. In each case, we're going to solve for x. So move the 8 to the other side, it becomes negative 8. Move the minus 3 over, it becomes plus 3. So my two solutions for this equation are x equals negative 8 and x equals 3. Remember from the lesson on this topic that we can have three possible solutions, three possible scenarios for our solutions. We could have two answers, like we have here. We could have one answer, or in some cases we could have no answer. So all three scenarios are acceptable. Again, one equation is only going to have one scenario, but all three are possible. In B, we're going to do the same thing. We want to factor it. So let's check. Can we common factor? No. Is it a difference of squares? No. Are there any perfect squares? No. Is it a complex trinomial? Yes. And it's a complex trinomial because of that value in front of the x squared. So, because it's a complex trinomial, that means we're still doing product and sum, except now the two numbers have to multiply to give us 2 times negative 2, which equals negative 4. So again, remember, product and sum, we're multiplying the a value by the last value, and that's what the two numbers have to add to. The sum is still going to be that middle number, so 3. So I'm looking for two factors or two numbers that multiply to -4 but add to 3. In this case, the two numbers are going to be 4 and -1. And again, if we want to check this, well, 4 times -1 equals -4. 4 plus -1 equals 3. So that does work out. Now that we're solving our complex trinomial, or we're factoring it, we need to use decomposition. So that middle number, or that plus 3x, is going to be broken down into our two factors. So 4x minus 1x is what that 3 gets broken up into. Minus 2 equals 0. And now we're going to solve by grouping, or factor by grouping. So we're going to look at our first two terms and our last two terms, and we're going to common factor each part. So if I common factor the first two terms, I can take out a 2x, which leaves me with x plus 2. The goal of the second, of common factoring the second pair, is to make sure that I end up with the same bracket. So in this case, I'm going to factor out a -1. I'm going to end up with x plus 2, which is the same bracket, so I'm on the right track. Now I can see that each term has the same bracket, so I can factor that out. X plus 2 times the remainder, 2x minus 1. And it's still set equal to 0. So these are our two factors now. Now that I have them, I have to set both of them equal to 0. And again, remember, the reasoning is, if I have two numbers or two terms and they're multiplied to equal 0, one or both of those terms has to be 0. So one or both of these brackets has to be equal to 0, which is why we're setting them both equal to 0 individually. So x plus 2, solve for x, move the plus 2 over, x equals -2. For the second one, a little bit of an extra step, move the -1 over, it becomes +1. Divide by 2, we get x is equal to 1/2. So in this case, we factored it, we're still solving the equation, so we have to set each factor equal to 0, and we get that our two solutions are x equals -2 and x equals 1/2. C is a little bit different. X times x plus 1 equals 2. In this case, we haven't solved, or we don't have it in standard form yet. So what I need to do first is I need to use distributive property to multiply that x through, and then I'm going to have to move the 12 over. So I have to get all my terms onto one side. So in this case, x times x is x squared, x times 1 is plus 1x equals 12. Now I want to move the 12 over to get it to the same side. So x squared plus 1x minus 12 equals 0. So now I have it in standard form and I have it set equal to 0. Now I can start factoring. And then again, I'm going through that kind of process, or that checklist that we did when we talked about factoring. Is there a common factor? No. Is there a difference of squares? No. Is it a perfect square trinomial? No. Is it a complex trinomial? No. So the only thing remaining is that it's a simple trinomial. So in this case, we're looking for two numbers that give us a product or multiply to -12, or give us a sum, and give us a sum or add to 1. So what two numbers multiply to -12 but add to 1? In this case, my two factors are going to be 4 and -3. Again, if we want to check that, 4 times -3 equals -12. 4 plus -3 equals 1. So that does work. Because it's a simple trinomial, put both factors into the bracket with x. So x plus 4, x minus 3, and it's still set equal to 0. Now that I've factored it, I'm going to set each factor equal to 0. So x plus 4 equals 0, x minus 3 equals 0. And now I need to solve both equations for x. X equals negative 4, x equals positive 3. Those are our two solutions for this quadratic equation. Or another way of saying it, the two roots or the two x-intercepts for this quadratic equation are negative 4 and 3. The other method for solving a quadratic equation is using the quadratic formula. And this can be used if you can't factor the standard form. And it can also be used if you can factor it. So regardless of the situation, as long as you have it in standard form, you can use the quadratic equation. Now that being said, it may be faster to use factoring if you understand the patterns and the steps to factor, because the equation can be a little bit cumbersome or long. But the quadratic formula will work regardless of the situation as long as it's in standard form and it's a quadratic. Again, factoring might be faster, but just be careful of what the question is asking you to do. If the question is asking you to solve by factoring, you still have to solve by factoring. You can double check your answer using the quadratic formula if you really want to, but again, just make sure you read the question. So rather than factoring, we have this equation, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And the a, b, and c come from the coefficients of the terms in standard form. So a is coming from the x squared, b is in front of the x, and c is the constant or the value on its own. Keep in mind that the plus and minus in the equation means that there will be two answers. Now, in some cases, depending on what the situation is, you may be adding or subtracting the same value. But again, you should break off into two different parts at the end. So let's go through solving each quadratic equation using the quadratic formula. So we only have two examples here, but they are going to be slightly different. In A, we can see that it's already in standard form. So it's helpful to just label our A, B, and C values. So we get x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I'm going to plug in my values. So negative, because the negative does come from the equation, negative 6 for the actual value, plus or minus the square root of negative 6 squared, minus 4 times 5 times negative 2. Again, make sure you're taking the sign in front of the value as well. And then 2 times 5. Here, we're going to simplify as much as we can. So negative 6 just works out to positive 6, plus or minus the square root of 36 minus 4 times 5 times negative 2. So we get minus negative 40, all divided by 10. We're going to keep going and simplifying. 36 minus negative 40, or 36 plus 40, becomes 76, divided by 10. So here's where I would suggest that we can split off. So we've simplified it as much as possible. Again, it may have taken a few fewer steps for you. Again, I'm just kind of going through and showing the full steps just to show where all the numbers are coming from. So here we're going to split it off. We're going to have x equals 6 plus the square root of 76 divided by 10. And the other option is going to be x equals 6 minus the square root of 76 divided by 10. Here we can go through and solve now. So 6 plus square root 76 divided by 10 gives us a value of 1.47. And if we do 6 minus the square root of 76 divided by 10, x equals negative 0.27. So these are our two solutions to the quadratic equation, or the two x-intercepts. So you can see that the x values aren't nice numbers, so if we tried to factor this, it wouldn't be possible. For b, b is similar, except it's not in standard form yet, so I can't pick out my a, b, and c value. I need to move everything to one side first, so it's set equal to 0. So in this case, I'm going to move the 21 over to the other side. I'm going to get 3x squared plus 7.5x minus 21 equals 0. So if you decided to label originally a, b, and c, that's fine, but keep in mind that 21 has to move over, so when it moves over, it becomes negative 21. So just keep that in mind when you're doing, or when you're trying to solve these questions. Once I've labeled my a, b, and c, after getting it into standard form, I can take the formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I start plugging in my values, so negative 7.5 plus or minus square root of 7.5 squared minus 4 times 3 times negative 21, all divided by 2 times 3. X equals negative 7.5 plus or minus 7.5 squared, 56.25, minus 4 times 3 times negative 21. So minus negative 252. All divided by 6. Keep on simplifying and calculating. X equals negative 7.5 plus or minus 56.25 minus negative or plus 252. We should get 308.25. All divided by 6. And here again, now we can split off into our two different solutions for adding and subtracting. So we get x equals negative 7.5 plus the square root of 308.25, all divided by 6. And we get x equals negative 7.5 minus the square root of 308.25, all divided by 6. And this will give us our two solutions. So negative 7.5 plus the square root, 308.25 divided by 6, get 1.68. And if we do the same thing, but negative 7.5 minus the square root of 308.25 divided by 6, we get negative 4.18. So here we have our two solutions, or the two x-intercepts for this quadratic equation. So two different scenarios, but as long as you get it into standard form, you can find your a, b, and c value and plug it into the quadratic formula. Again, just make sure you're careful to use the quadratic formula exactly. There are many errors or many spots where you can kind of create small errors, usually with positive and negative signs, that could change your answer in the end. Moving on from that, we are going to look at the last unit that focused on trigonometry. So there are two types of trigonometry, and the first one we're going to look at is right-angled trigonometry. So right-angled trigonometry was your SOHCAHTOA or your sine, cos, and tan ratios. Again, remember, right-angled trigonometry was only for right-angled triangles. In this case, the three ratios are sine, cos, and tan. The steps for solving right-angled trig or right-angled triangles: first, you want to label your sides. You should always be able to label your hypotenuse because it's opposite in 90 degrees, and then making sure when you find your reference angle, you can do the opposite, or you can find your opposite and adjacent. Keep in mind again that the opposite and adjacent can change depending on what angle you use as your reference angle. From there, you should figure out what two sides you're dealing with, and that will direct you to one of these three ratios. Sine is opposite over hypotenuse, adjacent or cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Just keep in mind that this little symbol theta represents our angle, and these represent side lengths. If you're solving for a side, there are two possible options or scenarios that you may come across. One, missing pieces on the top means we have to bring up and multiply. And the second scenario is the missing pieces on the bottom, so you have to switch and divide. And if you're solving for an angle, the one step that you have to do always is you have to use the inverse. So again, this is what it's going to look roughly like. Sine, or the inverse of sine, or sine -1 of the opposite over hypotenuse. So again, we'll look at an example of this, but if you want more detailed examples for each ratio, please go back and look at the lessons. So what we want to do in this example is to solve the following triangle. And what it means by solve the following triangle means basically find all sides and angles. So you need to find all the sides and angles in this triangle. We have one side, one angle, and two angles. We can find this third angle without using any trig by doing 180 minus 42 minus 90. Again, because all angles in a triangle have to add up to 180. So we know now that this angle is 48 degrees. In order to find my other two sides, I need to first label my triangle. So across from the right angle is always going to be our hypotenuse. I'm going to use the 42 degrees as my reference angle. So that means the side across from it is the opposite. And the side beside it, that's not the hypotenuse, is the adjacent. In this case, I need to find two different sides. So I'm going to have to use two equations. The first one, I'm going to deal with the opposite and the hypotenuse. And if I go back up to my ratios, the only ratio that has O and H, or opposite and hypotenuse, in it is sine. So that means for the one angle, I'm going to use sine theta equals opposite over hypotenuse. I'm going to fill in my information that's given. So sine theta, my angle is 42 degrees. The opposite is 13 over the hypotenuse, which I don't know, so I'm going to label as x. In this case, the missing piece is on the bottom, so I have to switch and divide. So the x switches with the sine 42. I get 13 divided by sine 42. And then x equals 19.43. If you're not getting that answer, again, remember that when dealing with trig on our calculator, we have to make sure it's in degree mode. So if it's not in degree mode, please make sure that you switch it over to that. If you're having trouble, you may have to Google with your specific calculator model just how to change it to degree mode, and worst case scenario, take a picture of your calculator and let me know, and then I'll see what I can do. So we found our hypotenuse. So the next step is going to be, again, using that same reference angle and trying to find the other piece. In this case, the adjacent. So I'm looking for a new formula or a new ratio that deals with, and I'm going to keep using the opposite again because I do know that that side is correct. So there may have been a calculation error. I may have gotten the hypotenuse wrong when I calculated over here. So I'm going to stick to using the opposite. So the only ratio that deals with the opposite and the adjacent is tan. So tan theta, the formula is opposite over adjacent. I'm going to plug in what information I know. Tan 42 equals 13. Adjacent we'll call y. Again, in this case, the missing piece is on the bottom. So we switch the two and divide. So y equals 13 divided by tan 42. And I get that y is equal to 14.44. So that's the length of the adjacent. Again, when you're solving a triangle, there's not one way to do it. There's multiple ways you could do it. You could have found the angle using trig if you really wanted to. You could have used the angle of 48 as your reference angle, which would have caused you to rearrange your opposite and adjacent, which may have caused you to use different trig formulas or trig ratios. Again, it's up to you how you solve it, but as long as you're using trig in some form, that's fine. Moving away from right angle triangles, we are going to be looking at non-right angle triangles. For non-right angle triangles, there's two scenarios, or there's two laws that you could be using. The first law that we're going to look at is the Sine Law. And for Sine Law, we're looking at solving for sides and angles. So there's one formula that you can use because it doesn't really change. And that is sine A over little a equals sine B over little b equals sine C over little c. So the ratio of an angle and its corresponding side, or the sine of an angle and its corresponding side, is equal to sine of another angle and its corresponding side. So basically, if I'm looking at a triangle that's not a non-right angle triangle, let's call it A, B, C. The corresponding side for A is going to be the side across from it, same for B, same for C. This pair, or the ratio of sine of this angle and that over that side, is equal to the ratio of sine B over its angle, and its side, corresponding side, and same with C and its corresponding side. So again, when we talk about needing a full pair and half a pair, that's what we're referring to when we're talking about pairs. So for the first one, we want to solve for the missing side or angle. In this case, we're looking for the missing side. So as we go through to solve this, we need to make sure that we have a full pair and a half pair. In this case, we can see a half pair. We have the angle, but we don't have the side. In order to solve, I need to have a full pair now. If I look at C, I have the angle, but I don't have the side, so I can't use that one. And if I look at B, I can see that I have the side, but I don't have the angle. So right now, I can't use that one either. However, because I'm given two angles in a triangle, I can figure out that third angle. So 180 minus 39 minus 80 will give me that third angle, which is 61 degrees. So now that I know that third angle, I have a full pair. So in this case, I'm going to do sine big B over little b equals sine A over little a. I'm not going to worry about sine C and little c because there's not enough information there, and I'm only going to be dealing with two ratios at a time. So once I write out my formula, I'm going to fill in my missing or my given information. Sine big B, or the angle, is 61, divided by the side length is 32. Sine of big A, or angle A, is 39, over side A, which is unknown. Once we plug in our information, we can cross multiply to get rid of these fractions. So we get A sine 61, or A times sine 61, equals 32 times sine 39. Now I want to move the sine 61 over to the other side to isolate for A. By doing so, I'm going to end up dividing by sine 61. And this just becomes one calculation now. You may want to do it in steps by solving or simplifying the numerator first, divided by the denominator, and then divide by the denominator. Or you can do it all in one step depending on what you're comfortable with. I'm going to do it in 2 steps. And if you do it in multiple steps, please try to keep some decimal places as you go through and solve. If you do round too early, then you could get the wrong answer. I'm just going to move this up. And then in the end, we should get our value for A works out to be 23.02. In example B, in this case, we're solving for the missing angle. So again, we want to look for our full pair and our half pair. Again, I can see a full pair here. I have the angle A and side A. And here, the side that I'm looking for, I have half a pair. I have the side and I'm missing the angle. So that is enough information to start using the sine law. It's a full pair and a half pair. So sine A over little a equals sine C this time over little c. Again, with the B pair, I'm not going to worry about it because there's no information there, or I'm not trying to find any information. If I did have to, I would do one equation first to find angle C, and then I would go back and do another one with my given information and my full pair and half a pair to find out whatever I needed to for B. Once I write out my formula, I'm going to fill in with my missing information. So in this case, sine angle A is 75 degrees divided by side A, which is 13, equals sine C, angle C is unknown, divided by side C, which is 9. I'm going to cross multiply, get rid of the fractions. 9 times sine 75 equals 13 times sine C. Now we want to work on isolating C. First thing I'm going to do is move the 13 over. Becomes division. So 9 times sine 75 divided by 13 equals sine C. And this is somewhat similar to what we would have to do with right angle trig for solving for an angle. If I want to isolate C or get C by itself, I have to move the sign over or cancel it out by doing the inverse. And if I were to do the inverse on one side, I would have to do it to the other. So the sine -1 of this ratio, 9 times sine 75 divided by 13. And that is going to give me my angle. So when I go through and I calculate this, again, you may want to do it, make sure you just move this up, you may want to do this in a couple steps. Simplify the numerator. So 9 times sine 75 is 8.693 divided by 13 equals C. And again, you could keep on simplifying if you wanted to. 8.693 divided by 13, 0.669. And then finally, shift and the sine button to get the inverse. So sine -1 of 0.669 should give you an angle of 41.989, which is close enough to 42 degrees. So again, a lot of extra steps there to actually just go through and simplify before we actually did the inverse. Depending on how comfortable you are with your calculator, you could go right from this last step down here all the way to the answer, if you're comfortable with your calculator. If not, again, please do it in steps. There's no harm in doing that, just to make sure you get the right answer. Moving on from the sine law, the other law would be the cosine law. So again, we're still dealing with non-right angle triangles. Now for the cosine law, this does change depending on what side you're going through. So again, we did talk about this in the lesson, so please go back and review that if needed. But basically, the main thing that you want is the side you're looking for, you should be given its corresponding angle. So we see in all of them, the main things that pair up are with the side that we're looking for is that we have the angle. And then everything else, the other two sides, for example, the first one, AB, those are two sides that we should be given. Again, capital letters represent angles, lowercase letters represent sides. One thing to look for, or to help identify if we have to use cosine law, in order to solve for missing sides, you need to have two sides and a contained angle. So what we mean by that is you have a side angle side sandwich, or a sandwiched angle. So let's say, for example, we are given angle A. We should be given this side and this side. So we have side, angle, side. That would help us solve for the remaining side. We have a sandwiched angle, side, angle, side. So let's just say, for example, 10, 45 degrees, and 13. This is an example of a sandwiched angle. And again, it doesn't have to be this side. It doesn't have to revolve around A. It could be, again, revolving around C, and we're looking for side C. Or it could be revolving around B, side, angle, side, and we're looking for side B. So again, it doesn't matter how or which sandwiched angle you have. Just keep in mind that that's what you need to have in order to solve for a missing side. And again, it should be pretty clear that it won't be sine law, because again, sine law, you're looking for that full pair and half a pair. So in this example, we want to solve for the missing side length, which is B. We do have that side angle side sandwich, so this does work for cosine law. Actually, I'll leave that up there. So because we're looking for side B, we could go back to our notes or the top and look at that specific formula for side B. So B squared equals A squared plus C squared minus 2AC times cosine B. Do not forget that cosine B. I find people tend to forget that part. B squared equals A squared plus C squared. So in this case, again, we can label it specifically from our triangle. So A would be 13 squared, C would be 26 squared. But again, it doesn't really matter, because we can add two numbers in any order, and same with the next part, we can multiply the two numbers in any order and it won't change our answer. But keeping it consistent with how it's labeled, A is 13 and C is 26. And then cosine B, or angle B, so cosine 81. The next step I'm going to do in two parts. I'm going to simplify everything before the subtraction, and I'm going to simplify everything after the subtraction, just to make sure that I enter everything properly. So 13 squared plus 26 squared is 845 minus 2 times 13 times 26 times cosine 81 So minus 105.75. B squared equals 739.25. Now we're not quite done because this is b squared, but I want b. So in order to get b by itself, I have to take the square root of 739.25 and I end up with 27.19 as my missing side length. So that's how you can use the cosine law to find a missing side length. To use cosine law for angles, we are going to be using a different formula. So that's different from sine law, where we did use the same formula. However, cosine law, we're going to be using something a little different. Technically, it's the exact same formula as the previous one, where we looked at solving for sides. However, we've just rearranged it to solve for c. So the steps are going to be a little bit different. But again, the main thing you should be making sure that you have paired up is that the angle c is paired up with, or the side of the angle you're looking for should always be the subtracted term. So again, remember those corresponding sides and how they pair up, so how angle C pairs up with side C. If we look at this little triangle, angle C, side C is directly across from it. So that's how you should make sure that your sides, or you've entered the information correctly into the correct spots or the right variables. In order to solve for a missing angle using cosine law, you have to have all three sides. So this one's pretty straightforward in being able to determine which angle you're looking for, or which law you're going to use. You have to have all three sides in order to use cosine law to find an angle. So if I look at the one example, I want to solve for the missing angle, which I see down here is A. I do have all three sides, which means I'm using cosine law. You could also double check, could you use sine law? Well, you have half a pair here, but if you look at all the other pairs, they are all half pairs as well, with no way to find those angles. So again, sine law wouldn't work, so you have to use cosine law. Because it's for angle A, cosine A equals b squared plus c squared minus a squared. So again, that angle we're looking for and its corresponding side is being subtracted. All divided by 2bc. So cosine A is equal to b squared is 24 squared plus c squared, which is 18 squared, minus 26 squared. All divided by 2 times 24 times 18. Cosine A equals, I'm going to again split this up into two parts just because there's a lot of chances for errors in our calculations. So I just want to make sure that I'm not getting the wrong answer just because of the calculator. So 24 squared plus 18 squared minus 26 squared, 224, divided by 2 times 24 times 18, 864. I can simplify this. Cosine A equals 224 divided by 864. I get 0.259. And again, one way to check this value or this ratio should be less than 1 when we go through and do it. In this case it is. Now the last step, anytime we have to solve for an angle, we have to use the inverse. So to get A by itself, I move the cosine over, becomes cosine negative 1 of 0.259, and I get an angle of 74.97, so 70 5 degrees. So that is my missing angle. So again, this video looked at the second half of the unit. It looked mainly or only at solving quadratic equations, whether it was solving by factoring or solving using the quadratic formula. And then we looked at trig for right angle triangles, SOHCAHTOA, and non-right angle triangles, sine law and cosine law. And again, looking at the different ways we can solve for angles and sides in both scenarios. So again, if you do need more information or more in-depth explanation, please go back and look at the individual lesson videos to help you with that.